Instructor from Austria.
Yeah, good afternoon, ladies and gentlemen. Mr. Chairman, thank you very much. Ladies and gentlemen, I'm happy to be here to make a presentation about an European research project which was carried out during the last 2 years in the context of so-called CEDRE. CEDRE is standing for Conference of European Directors of Road, which means at the end that the European Road Administration brings sometimes ideas and at the end also some money together and try to find out in the different areas what's going on and where could be the next steps into the future. And one of these projects was this project called named ISABELA, which is dealing with something so-called social performance indicator, and it's a pleasure for me to present this project here, which we could finish in fall last year. So what's the content of my presentation? At first I will give you a short introduction, because I think you should know what's the objective of the project, how was the working program set up. Then we spend a lot of time in investigations, finding out what are the requirements and expectations. So we're moving a little bit from the technical side here into another field, which as I'm a civil engineer, not really that area where we usually work. We looked at the indicators, which are important. We have heard some presentation where colleagues are using indicators more from the technical point of view. So we had to extend a little bit our view in the social area. One big topic was at the end, of course, the modeling and the implementation. Implementation is an important part in all of this CEDRE project because it's not just theory. It should be a little bit more. It should be bringing the theory in practice and finding out, is that what we found out really a practical way of improving our systems, of solving our problems, or do we still have here some gaps where we do some research? So I will also present with a few slides a case study we have done in Austria. And finally, of course, that's important after such a project, what's the conclusion? So ISABELA, it's a nice lady's name, so the question is, who is ISABELA? It's at the moment a nice little lady. We grew up with her in about 2 years. Now we are ready to send her out into the world so that she gets more and more experience, that she becomes really a big lady. So ISABELA is standing for integration of social aspects and benefit into life cycle assessment. The topic which was addressed was asset management and maintenance. So it was a call 2014. It was the topic C, social benefits and costs. So and CEDRE gave us a general framework about the different areas. As I mentioned before, we are not really experts in the topic in the social area, so the idea was to have a rather big consortium available, so with many colleagues and friends from the different countries, and you can see here, beside PMS Consult, we were the leader, and we also were in the responsibility of the technical advisory board. We have colleagues from Slovenia, from SAC, from Serbia, University of Belgrade, IMC from Switzerland, from Germany, Technical University of Braunschweig, from Portugal, ELNEC, Sestel, Slovenia, and also here from France, where our partner was Logerod, his name. A colleague was Philippe Lepere, who really supported us here from the French-speaking part of the world. The project duration was approximately 22 months. Took a little bit longer because what we found out is that the investigation cost a little bit more time in the beginning of the project, and we tried to take as much as we could from the literature, from the investigation into account. So the objectives of ISABELA, or the main objective, is the definition at the end of something so-called a holistic framework for social key performance indicators and social benefit modeling in form of social effects. We looked at monetary and non-monetary effects. Also the terms social backlog and social risk were included. As I mentioned before, the framework was given. We had to focus on 4 main areas or aspects. It was the availability and the disturbance, so travel time, vehicle operating costs, and other aspects here. Road safety, of course, accidents, accident costs related to the different types of the asset conditions. So it was not just focused on pavement. So also the other assets, which maybe have a certain influence to the safety of a road infrastructure, were taken into account. Environment, especially noise, air pollution, greenhouse gas emissions and so on. And really a new area, a new field, the socio-economy, so asset value, but also wider social effects. When you look at the graph here on the right-hand side, we try to draft the old way or the technical way. I do not want to say it's the old one, but it's the technical way how we assess our road infrastructure asset. We have the data, we have some stakeholder expectation requirements, strategic influences. We do some life cycle analysis, cost-benefit analysis, so different approaches for the different types of assets, and what we're getting out are technical effects. We get the technical backlog, something like technical risk, and mainly the direct costs. But we shouldn't forget there's another world, and that's drafted here on the right-hand side. It's the social world. We have to look when we identify or assess a construction program, also assess it from the social point of view. What's the social effect of maintaining a road section, including different types of assets? What is the social backlog? What is at the end the social risks, and for the whole society something like the social costs? The working program is drafted here in these two graphs. I do not want to go too much in detail here. We had a hierarchical structure. Each working group was the basis for the following up working group. At the end, we also had the implementation, or to produce some practical guide for the implementation of social indicators. In total, we had 5 working packages which were working over the 2 years in total. Investigation, so that's not me here. So that's just a friend looking for some troubles on his road. So investigation is important. So when we look at these 4 areas, safety, availability, environment, and socio-economy, there is a certain relationship to the different types of the stakeholders, and that's important to find out at the beginning. Because you can imagine when you're using a road, you have different expectations in comparison when you're living beside the road with your family. But also from the engineering point of view, from the road administration point of view, there are also different requirements and expectations. And at the end, we have to take all these expectations and requirements in the 4 areas into account. So what we have done beside the investigation on the literature, we also looked at different projects. We could identify approximately 30 different stakeholder requirements. 63 expectations were defined and grouped, 15 to users, 11 to neighbors, 8 to financial institutions, 8 to road authorities, and 21 to the society. So you see here a big number of expectations coming from the society, expressed by indicators which are usually not driven by technical parameters. What we have done in addition, because we found out that's important, you have a big list of indicators. Let's speak with the road administration, which are the addressee of this project, and see what's their opinion on the different expectations, and at the end on the requirements. So we collected the indicators, went out to the different road administration, made some interviews to get the first impression what they think about our findings. So at the end we had more than 100 indicators on the list. We grouped them into our 4 areas: road safety, availability, disturbance, environment, socio-economy. We made subgroups of it, so go more in detail, especially when we come to the modeling. It's important to have here a clear definition. So just as an impression here, the list of the indicators, you're not able to read it here from the audience, but what we have done here was already a selection of indicators where we knew at the end we can calculate these indicators. There are many indicators which we are not able to calculate. You need a very high number of data to fill the model. So we said, no, we do not want to have this, because always in the back is the practical application. So for the road administration to find out what are the social effects. An important discussion came up when we had the idea where it's the best place to calculate social performance indicators, social risk, social benefit, and we found out the best place, that's the opinion of the group, is a network level approach for the assessment of committed or recommended maintenance program. So you have your systems in place. We have heard here some presentations. At the end, you get the list of maintenance activities. Bridges, pavements, other assets which are along the road. The question is, and usually these construction programs or maintenance programs are something like cross-asset programs, is what is the effect and the consequence from the social point of view. And that is an approach which should be done on the network level, because that's the place where you usually bring the different requirements from the different assets together. So the modeling will be usually based on the assessment of so-called maintenance project, where a maintenance project is a accumulation of different maintenance activities on a road section, affecting different types of assets. That's not a limitation of the project. We said that's our recommendation, but at the end what you can do, you can also apply your models in a pavement management system or in a bridge management system. Of course, at the end when you make a maintenance project, so a project over more than one asset, you should run the analysis again, because there are not independent effects from the different assets. So the calculation of social effects of maintenance project was the main recommendation. So accumulation over the whole network at the end. So you have on single road sections the maintenance project, but what you can do in the next step, you can accumulate over the whole network, so that you have at the end a number for the maintenance program in a certain year on your whole network, looking at the social benefit, the social backlog, and the social risk. Also, I mentioned that before a little bit, are the model requirements. The input parameter must be available. Otherwise, it's waste of time implementing such complex algorithm. Next point, model should not be too complex and can be applied in practice. We should understand what we calculate, because at the end we need to sit down and assess the results, and if we don't understand what such a model is bringing up, we will get in big troubles. High probability that the model can be implemented into an asset management tool. It's important for the practical application. That's what we have done at the end in the case studies, to find some commercial asset management product where we can implement our ideas. Model should use existing correlations, and of course it needs to be adjusted. We defined the models from a very general point of view. At the end, when you go down to your network has specific requirements, specific preconditions, and then you have to adjust the model to the local situation. Model can be applied on maintenance project. I explained that before, and the model describes social effects in an appropriate form, like effect is recognizable, effect is related to asset management. We didn't look at social effects which are far away from the asset management point of view. Effect can be monetarized. That's what we found out during the modeling phase. The best is to express the effects in monetary terms. That's easy to understand in comparison to scales or other types of indicators, and the effect can be used to calculate our social key performance indicators. So this slide just shows you the basic idea. We have, when we look at the effects, we have the social savings. If we do something, there is a benefit, and this benefit can be expressed by using our models into something so-called social savings. Nevertheless, we shouldn't forget the other side. We have social costs. If you apply a maintenance activity, you close 1 or 2 lanes on your motorway, you will have immediately negative effects. And that is what you have to take into account in all 4 areas. In the environment, in the safety, in the social wider economy effects, in all these 4 areas. And then you do a simple comparison. At the end, of course, it's not that simple, but that's the basic idea behind. So the definition of the social benefit was also included here. As said in one of the first meetings, it's important that we speak the same language. So we need to get a definition out of the project. What we understand as a social benefit is defined here as a positive or negative societal consequence of any intervention strategy on one or more stakeholders, which is related to disturbance, availability, safety, environment, and socioeconomy, so our 4 areas. We also defined the term social backlog. There is a technical definition existing, the social monetary consequences of and effects of not fulfilling predefined expectations. So if you have strategic targets and requirements, you're not fulfilling that with your maintenance, with your construction program. What is the social backlog on that? And then also the third one, caused a lot of discussion, was the social risk. Is evaluated as the product of the probability that a predefined maintenance strategy does not meet the expectations of the stakeholders. So if I apply maintenance program, is it a good one? Does we fulfill the expectation of the different types of stakeholders and the resulting social consequences, considering, of course, at the end, different uncertainties within the asset management process. That's the idea of the social risk. The implementation, I already mentioned that. We said, in principle, you can use it on the object level, in a pavement management system, in a bridge management system, but at the end, we would like to assess more on a general level, we would like to assess maintenance programs, projects, so that we get a certain idea about the social effects, about our social indicators on the network level. Implementation, how? It's the next question. It's not just where, how. We looked at different procedures, how to implement that. You can't read it here. So two main areas are looking especially on the data, on the availability on the data, on the modeling, but also at the end, you need something like an asset management system where you would like to implement the models. It's too difficult to calculate it manually. Excel will not reach the goals of an asset management system here in this project. So you have to find out, is my asset management system really ready for calculating social performance indicators, or is it necessary to look at some extensions? I come to the last point of my presentation. I promised you to speak about some case studies. I would like to present here the Austrian case studies. The reason is because I'm from Austria, so it's easier for me to explain the Austrian case studies. We had a second case study in Belgium. Our French colleagues analyzed the French network. It was a part of the Flemish motorway network. As I mentioned, we used for the case studies commercial software system. One was Loggerode here from France. The second was T-Teams, a Canadian product which will be used in many European countries. And we looked on a motorway. It's the A4 from Vienna to Hungary. And there are two ideas on the motorway. There is planned an extension, including a reconstruction, and the second scenario is not doing the extension, just repairing the motorway and bring it up to the necessary level. So, extension of the motorway, we have a high increase on traffic on the important east-west corridor. It's the motorway also between Vienna and Budapest. You see here some numbers, 50,000 vehicles per day, per direction, 4,500 trucks. It's at the moment, most of the parts are a 4-lane motorway, so 2-lane on each carriageway. In addition, on almost 13 kilometers of the motorway, the existing old cement concrete pavement will be reconstructed to the poor pavement condition. We have troubles with that type of pavement construction. And we have a maintenance program, a list of maintenance projects on this motorway for the next years. And the idea was just taking this maintenance project, it's not just pavement, it's also including other type of assets, and assessing it by using our models. So for the whole corridor, we didn't just look on the extension part, we included the whole corridor. So we selected, in mutual agreement with CERE, the aspects we were looking. We didn't look at all 4 aspects, we took out 2 of them. It was the disturbance and the availability. The second was the safety, so time loss to the maintenance project, and effect on detours. Very intensive maintenance work always causes that people are leaving the motorway using parallel national roads, state roads, sometimes community roads, where you have, of course, negative effects. And when you look at the social point of view, you have to take this into account. Accident costs as an effect of course, improving the road situation. I do not just say road condition, it's the whole situation. But of course, when you do maintenance activities, also the number of accidents can happen, that also this number are increasing. So you have both costs and savings included. So what I would like to address is in this on this slide are the figures here on the left-hand side. What you see here, it's the comparison between the savings and the cost. So the green ones are the savings. You see here on this graph, we have quite a high number of so-called long-term saving, but during the construction extension, we have very high social costs. If I compare it with the so-called the minimum strategy, just replacing some parts of the pavement to bring it up to the minimum level, the long-term effects on the saving, of course, are much lower, but also, we should not forget, the negative effects at the end are much lower. So what we need to do at the end is to compare, to calculate the difference between our costs and our savings. And here for the scenario, including the extension, and that's the profit. Let's say it's the profit. I'm not an economic expert. It's some sort of social profit. We can here see that is a positive effect in total. So the savings are higher than the costs, but it's the same if you just do the minimum one. So at the end, what we can get here is a first idea. What is the social effect if I do this extension on this part of the A4? So I come to the conclusion. Socioeconomic impacts assessment can certainly be performed with ISABELA models and methodology in most of the existing asset management system. That's what we found out. We didn't recommend it very complex model. We looked at the availability of the data. We know more or less in Europe here what will be collected on the road infrastructure, what condition data, how the bridges will be assessed, all the other assets are available from a certain amount of data. That's important, and the recommendation is if you take this model, you can simplify it, you can go more in detail into the model, then it should be possible to use it on your network. To perform a reliable and satisfactory assessment of the maintenance policy, road administration, we have to get a more socio-economic information. It's not just the number here, it's the way how we communicate with the decision makers. At the moment we are very technical driven, and that's not so easy because most of the decision makers are not technicians. We have to find a way to explain what we really would like to have on our roads. And that's not an international roughness index, that's not the minimum RATEP and so on. That's maybe they understand, but it's better to speak in that language where the decision maker have learned to speak. And social performance indicator can help us in this form of communication. The results, as I mentioned that before, can be used on different levels for single assets or for maintenance project and should be integrated in the decision process. It's not easy to say, okay, now I implement it. It's a stepwise procedure, starting with some models, with some parts, and then increase it by time. In general, the assessment can become a complex issue. It's a fact. A simplified approach is, of course, recommended to use existing data, existing models, and to help the user to understand the calculation process and the results risk. I think that's very important at the end to say that it's complex, but there is a way how to integrate it and to help the road administration authority to underline the needs of investing money into their road infrastructure assets. Thank you for your attention.
Thank you, Alfred. Now we already finished with the last presentation. It's now Frank Howe from